We're going to end the course with a last chapter on a specific engineering application of statistical analysis, namely statistical process monitoring. Production processes are often subject to variability. There's two types of variability. There's the variability due to the cumulative effect of many small and essentially unavoidable causes, things that you cannot really control for. If a process operates only with these common causes, we say that it is in statistical control. The weather, whether there'll be a little bit more dust in the space when you manufacture your products than usual or not, whether the operator of the heavy machinery has a headache or not, that type of things. And then there's variability due to special causes, improperly adjusted machines, operators that systematically make the same errors. Perhaps you've purchased defective materials to produce your gizmos. The variability here is typically much larger than for common causes. And when that happens, we say that the process is out of statistical control. Statistical process monitoring aims to identify the occurrences of special causes and to eventually let the people who manage the process know that something unpleasant or undesired is happening. Why do we even need statistical process monitoring? I have this quote here from 1997. I'll read it off just because it's potentially one of the most visible, spectacular failure of statistical process monitoring, at least in the last 30 to 40 years. And it relates to the Challenger disaster. So NASA engineers did not identify the association between unexpectedly low launch pad temperatures and O-ring failures in the Space Shuttle booster rockets. They interpreted this critical signal as simply chance variation in the failure of the joints. For them, this was a common cause of variability. Lack of this insight was critical in the decision to launch the Challenger on its final and disastrous flight. And you might have seen some video footage of Richard Feynman showing the effect that plunging the O-ring into cold water had on the ability of the O-ring to maintain its structure and then to provide the right kind of seals. So the effect of the temperature is not a common cause here. It's a special cause. And it led to, well, the explosion.